Okay, we're going to have a closer look at the insides in the bowels of the radio, so to speak. But for that, I will need to undo the speaker, and I'll probably undo this capacitor too, to have a closer look at what's in the radio. I'll be back with an update. And oh yeah, the reason why also I'm going to unmount a couple of parts is that I'm going to give all the resistors in the radio a measuring, just to see what their value is and if they warrant a change or not. So yeah, stay tuned, and I'll be back with an update after a quick look around the radio. I finally managed to get the big electrolytic capacitor loose, but as you can see, it was a system with a metal band and a rivet. In fact, there are two rivets. One that attaches the metal band to the capacitor, and another rivet that attached the capacitor to the chassis, and specifically through this hole where my finger is pointing. So I had to take the mini drill and sort of wear off the head of the rivet so that I could push it back through the chassis. The damage is minimal, considering that it's the very first time I'm using this mini drill. Have never used, or rather, perhaps I did use something like it many years ago, but not nearly as powerful as this one is. Also, I disconnected the speaker. Interestingly enough, the speaker only has one wire soldered to it, which is this wire with the label, and in fact, they used the metal of the speaker itself, so in other words, the body of the speaker, as I surmise the minus or the mass connection. And as you can see, they even modified one of the wires of the speaker to be riveted to the chassis of the speaker. So that's interesting. That's a kind of a saving I wasn't aware of they did. Anyway, so this is the look inside of the chassis, and as I disconnected the speaker, I noticed yet another electrolytic here. So in fact, there are not 4 electrolytics in this radio, but 5. So yeah, the electrolytics are the first capacitors that will go, for obvious reasons. I mean, they are the ones that go bad most often. I'll see whether I can recoup the old capacitors, just to stay on the authentic trail. If I don't manage it, or if it's too difficult, well, then so be it. I'll change those for brand new electrolytics, and that's it. Also notice the speaker was attached via 2 very long screws, like this one. So 2 very long screws, I would say about 1.25 inches or something like that, so about 4 centimeters, and through a piece of metal like this, a spacer, but a very high spacer. Now, I think they did that mainly because otherwise the speaker would have been hanging far too low to this power resistor, which is, like I said last time, a can-dome resistor, and these get pretty hot. So my guess is they attached the speaker via these spacers to get enough air circulation around the speaker. Okay, so now I'm going to do the next part, which is to measure out the resistors that I can reach easily, maybe even a few capacitors, and then I'll start by replacing all the electrolytics in this radio. I'm also thinking about replacing this selenium rectifier. As far as I understand, it is a selenium rectifier, and I'm told these go bad quite often, and when they do, they really stink. So I'm not really prepared to have my house fumigated by a burning selenium rectifier, so I'll put in a simple diode, a 1N4007 or something like that, to change this rectifier. I might even add a power resistor to bring down the voltage a little bit, because I'm told the modern rectifiers are much more efficient than a selenium rectifier, which means that the voltage is also a bit higher. So putting a diode in series with a power resistor will bring down the voltage slightly so that it resembles more the power from a selenium rectifier. Also, I noticed that there is on the AC connector some blackish goo at the basis of the wire. I don't know if you can see it, but it's a little bit black. Now, I wouldn't immediately say that's a bad sign, but if you look at the black goo coming out of the connector itself, right here where my finger is pointing, then I'm not entirely at ease with using this one. It's quite possible that at one point or another this radio failed and provoked a short circuit, which went all the way down the electrical wire and all the way up to the connector. I'm not sure. I'll measure it. If it measures okay, I might use it for a couple of times just to test it. Okay, just in case you were wondering how the case of the radio looks like when it's removed of the red paint, well, this is how it should look. This is in fact the original layout of the box. As you can see, there's still quite a bit of red paint left within the ridges of the front, and it'll be a real pain to remove it, especially so since the one who spray painted it really didn't skimp on the paint. He laid it really thick on the front of the radio, but okay, I suppose with a lot of patience and a cleaning fluid, I'll manage in the end. It's also drab or beige at the bottom, as you can see, and down the sides, and even on top. Interestingly enough, this trace which you see here, is also red. But this isn't paint. In fact, this is where the tuning button used to rub against the case. So these are really nothing else but tiny little plastic particles which you could say burnt into the case of the radio. I don't know if I'll take that away, since it is part of the radio and how it was used and built. So this spot I think I will leave as it is. It's original, and even though it probably wasn't meant to be that way, well, they built the radio that way, and so I'm not going to mess with that. Also, as you can see, using acetone on plastic disfigures the plastic a little bit. It becomes a sort of a whitish pink. And the reason for it is that the acetone breaks up the little molecules that make out the plastic. And when you break up those little molecules, they absorb light much better than when they are the original long elastomer molecules. It's a little bit of chemistry, but that's the way it is. I could scrape off this layer, and as you can see, if I scratch it with my nail, it starts to glisten again. So I'm not sure whether I will polish it or I will use a different method to make it shiny again. We'll see. I still need to do a lot of cleaning of the case, so I still have a little bit of time to think about how I'm going to clean and bring back the original shine to the plastic. Also notice there is a crack down in the front of the case, right where my forefinger is. And I suspect one of the owners thought this crack is ugly, or was ugly, and decided to just give the whole cover a layer of paint, just to hide the crack. But hey, a radio is just like any other household object, is an object subjected to all sorts of mishandling and faults and you name it. This is part of the life of this radio. So no, I'm not going to repair this. I'm not even going to try to hide it. It's part of its history, so it can stay as it is. So now I thought I would open up this electrolytic capacitor, and I'll put the camera on a tripod and show you how I'm going to remove the insides of the capacitor cover or shell. I think it's a cardboard shell, and inside the capacitors are kept in place with something like wax or paraffin. So it should be interesting to see how they built it on the inside. I decided against taking off this metal band, which would have meant I would have cut through this rivet. But since I'm going to take the pains to rewire this capacitor and keep the original casing, which you can see, well, if I do the effort to keep this, then I'm also going to take the effort to keep the original rivets if possible. So give me a minute to set everything up, and then we'll proceed with gutting this old electrolytic capacitor. Alright, so I have the hot air gun ready, and I'm going to take a rag just to be on the safe side. I'm also going to do it slowly because I don't want to burn everything or mess up anything. So, well, let's do it. As you can see, the paraffin or the wax that was on top of the casing starts to melt. I'm not too fond of this sort of stuff because it's really dirty and all, but well, that's how they made these capacitors 50-60 years ago, and they used any sort of product which would do the trick to insulate stuff. So yeah, there you go. Now it's really boiling. Okay, let's see whether we can release it. Oh God, no, not by a long shot. But maybe I can release this. Yes, I can. So, ouch, this is hot. Okay, ow, ow, ow. Okay. There you go. I released the metal band. So that's okay. At least that's one thing done. Okay, so, well, let's keep on heating it and see if we can release it. I don't know if it'll work, but oh my, this is ugly. No, this is not it yet. Interesting thing here. I don't know what it is, but it feels like a sort of a paste, almost. Ow, 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 and it's incredibly hot. Whew. Ouch. Ow. Okay, oh well, this isn't going too easy. Okay, let's try the other end. Bloody hell, this is hot. Okay. Ouch, 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 ouch. No way. Okay, so I think I'm going to do the red end first, and then we'll have a look inside, because I have no idea what's inside the capacitor. So let's go ahead. This is really hot. Ow, ow, ow. Ouch. Oops. That's not so good. Okay. Well, I tore up the casing a little bit, but at least now we have a good view of the insides. I don't know if you can see it. Let's see. Inside there is what looks like a roll of aluminum paper, which is quite probable, of course, and there seems to be a sort of a plastic separator between the aluminum and the cardboard roll or cylinder. Okay, so let's heat up the whole thing and see if we can pull it from the other end now that I released one end of it. Whew. It's smoking hot. Bloody hell. This is really hard. Yeah, it's coming along, but it's really slow. Okay, so it just needs a little bit more heating. Alright, so let's see if it works now. Yes, yeah. There you go. Got it. But man, this is hot. I mean, really hot. It's so hot it smokes. Okay, so, well, as you can see, ow, it's a clean roll inside, nothing special, except perhaps for a layer of wax or something like that. But aside from that, it looks okay. And the capacitor itself is a dirty roll of, well, a dirty roll of aluminum paper covered with a sort of a waxy material, and on which three wires are attached. Now, The black wire is the ground wire, and interestingly enough, the ground comes out of the capacitor together with the green and the yellow wire, which are a 60 microfarad and a 250 microfarad wire. I'm sorry, the green is 40 microfarads and the yellow is 250. The red one is 60 and comes out the other end, like this. How or why they chose to build it like this, I have no idea. But it doesn't really matter. The only thing I need to do is to emulate this construction, but with new capacitors. I just hope I can fit them all into that little cardboard roll here, because there isn't that much space in it, so I have my work cut out. So I'll either start to look for capacitors which are small enough to fit inside, or I'll have to find another way to fit them inside this cardboard box. Anyway, this is it, guys. I hope you liked watching this installment of refurbishing and restoring a Westinghouse H-598P4, and I'll be back soon with another update to show you where I stand and what we'll do next to bring this little radio to life. In fact, I'm considering changing, at least for the moment, only the electrolytics and perhaps the selenium rectifier, and then try to start up the radio just to see whether there's still some life in it. But that will be for the next installment. So stay tuned, guys.